Alright, hello guys, I'm Ron and I'm here today to review a little bit more of Algebra 2 Trig. Today I'll be going over positive, negative, and zero exponents. We learned this in 8th grade, but it's always great to review. And if I have time in this video, I'll also move on to another topic. So, when we have exponents, and when we're dividing exponents, let's start with that. We can use the formula x to the a over x to the b will yield x to the a minus b. And what this means is that if you have x to the fifth over, say, x cubed, you'll get x to the 5 minus 3, or just x squared. Alright? And that's good to remember when you're asked to simplify something. So when you can use the same thing when you have x cubed over x to the fifth. And that would be x to the negative 2. And now you're stuck with a negative exponent. And usually we don't like that, right? It looks odd, ugly, right? So the negative exponent rule is x to the negative a equals 1 over x to the a. No, excuse me, x to the a. Alright, so in this case, this is actually 1 over x squared. Alright, so let's say we had a problem and it said simplify. It said, simplify 6 cubed over 6 squared. This would equal 6 to the first, or just 6. Now we can have, let's do 6 squared over 6 cubed. This would be 6 to the negative first, which is equal to 1 over 6. Okay? One thing that's very important to remember when you're doing this is that the bases of the exponents when you're dividing have to be equal. So you see, it's always x here. So if it was x squared over y squared, you can't simplify this. You can't divide it because the bases are not the same. Alright? Now when you have a zero exponent, say 1 to the 0, it would always equal 1. 2 to the 0 power equals 1. 3 to the 0 power equals 1. So anything x to the 0 equals 1. Alright? As long as x does not equal 0. If x does equal 0, then you'll get 0. Alright? So these are the three basic rules. We have the division here. We have the 0 power rule here. And we have the negative exponent rule here. Okay? And those are just basics of exponents. So let's go on to rational, fractional exponents. So in the video before this, I talked about radicals and the index versus the radicand, and all of that. So when we're doing exponents and when we have a fractional exponent, it really means that you're taking a square root or cubed root or something. So x to the mn, this is the rule, equals, n would be the index, x to the m. Alright? X would be the radicand, m would be the exponent. Alright? And n cannot equal 0. Because if n equals 0, then you can't take a square root. You can't take the root. You can't take the 0 root or something. So when we go into this, so this is the rule. And our first example could be, what is, let's go x to the 1/2. And x to the 1/2 is really just the square root of x to the first. Or the square root of x. So these two are equivalent. If you had the cubed root, x to the 1/3, that is the cubed root of x to the first, or just x. Okay? So say you had the problem, let's see here, 25, the square root of 25 x squared y to the 4th. Alright, now what does this equal? Well, you would take the square root of each one of these variables. So you'll get 5x y squared. Alright, so x times x is x squared, so the square root of that is just x. And y to the 4th, the square root of y to the 4th is y squared. Now say you were given a problem of 25 x squared y to the 4th, all to the 1/2. This is the same exact problem as number 3, based on this rule. So you would receive the same answer. We can rewrite it as 25x squared y to the 4th, which is the same answer, 5xy squared. Alright? And that's the basics of rational or fractional exponents. So now let's go into, just give me a second. Let's go into some factoring. I know a lot of my friends have a lot of trouble factoring, and they have trouble looking and finding how to factor, and what are the steps that go into factoring. Alright, so how do you factor a polynomial? We can start with a binomial. And when you're factoring a binomial, it's always easiest to look at the GCF. That is the first thing you always want to look at. So step 1 in any problem, look for GCF. And GCF is the greatest common factor. So look for numbers that every group of terms or variables has. It could be a number or it could be a variable. So before we go into, actually no, we could do binomial, but we'll start with a GCF example. So say we had 4x squared plus 2x. Alright? And said factor this. Alright? So what you would do is that, first of all, you'll see that both of the terms have an x value. So you could take out an x. You can also see that 4 and 2 share a common factor of 2. So you could take out a 2. And what you're left with is 2x plus 1. And how you get the inside is by dividing the entire binomial or trinomial by what you took out. And it should come out clean. What you would do now to find the roots of this is tee it up, like G used to say, and set each side equal to 0. Right, so this equals 0 at the top, this equals 0 here, and so each side you can set equal to 0. So x would equal 0, right? You divide by 2 on both sides. And 2x plus 1 equals 0. Get 2x equals negative 1, x equals negative 1 over 2. So those are the two roots. The second thing you should look at when you're told to factor, second step, is look to see if you can dots it. That's what it's called. Use dots. And what dots means is the difference of two squares, right? So difference of two squares, right? Dots. So to do with an example of dots, usually they are binomials, so I'll put them under here. Well, almost all the time they're binomials. So a very basic example, we could do x squared plus 36. The problem with this is that there's a plus, alright? And difference of two squares, difference, right, of two squares. So you have, and you know that x squared is a perfect square, and 36 is a perfect square, but you can't do anything with this because it's not a difference. But if we were to change it, and we made it x squared minus 36 equals 0, now we can work with it. So you set up your two bubbles, right? And then you put an x here and an x here, plus, minus, always. And you would put the square root of the other one here. So 6 and 6. X plus 6 and x minus 6. And when you were to tee it up, you get x equals negative 6 and x equals 6. Right? So dots is very easy. It's my favorite way of factoring, but usually it does not pop up because of the simplicity. In my next video, I'll go over factoring like double bubble, if you know what I mean. And eventually I'll go into factoring by grouping and factoring by completing the square. Thank you.